the LED Lady, and you're watching LED TV, your source of information for energy-efficient lighting. Despite the fact that LED lighting is something most of us have only recently heard of and explored, the truth is it's been in the making for over 50 years. It all started with a simple idea of getting light into small spaces, such as handheld calculators, to now serving a growing industry demanding for electronic devices needing illumination. The main reason for the growing development and acceptance of LED lighting is related to energy efficiency. Some of the movers and shakers of LED lighting entered and exited the industry, leaving behind important inventions that we still use today. And yet others were there for the entire evolving process of the industry, such is the case of my guest today, John Massa of Massa Enterprises. John grew up in Ohio, went to college in Indiana, holds several patents, studied an important number of languages, including computer languages. He is a microchip consultant and design partner, lover of analog, digital software, firmware, hardware, and he's a true techno dude. Welcome, John. Thank you for coming.
Thank you for having me, Lindsay.
So, John, when did your personal LED industry experience take place?
Oh, over the years. Lindsay, I'm a 50-year in the industry grandfather engineer. 50 years ago, they had LEDs for indicators, little tiny LEDs, T1 3/4 size. And from there, the ones that I made 50 years ago still work, so they don't die, they degrade. They have a lumen degradation. So I've been in the industry mostly as an electrical engineer in power supplies. I've done power supplies all my life. So that means I know a little bit about power supplies and the heat problems that they have. The other thing, light, was something I learned as working at the little theater in Austin, Texas, as the light and the sound guy. So the light and the power and the heat are the three big things about LEDs. So today we have LEDs that have matured, and now they're being used in every type of lighting appliance you can think of,
including light bulbs. And in fact, we have with you today, I'd love to find out what you have with us here to showcase a little bit about the difference between incandescent and LED. Is that right?
Yes, I would like to show you the difference, if I may.
Yes, please.
All right, this machine that we have is something that we use to test LEDs. We do a lot of testing of LEDs from China, and we make some of our own LEDs for streetlights. This machine, let me turn it on. As you can see, it has two light bulbs screwed in up at the top. It has an incandescent 60 watt, and it has a 6 watt LED. The difference in power is 10 to 1, because the older light bulb puts out 90% of its power as heat, and the LED does not. It puts out most of it as light. It has some heat involved with the electronics, but mostly light. So let's turn the thing on and turn on your LED. Now that's an LED.
Oh, incandescent?
Incandescent, 60 watt, and it shows on the meter as 60 watts. Now watch the meter when I switch to the LED bulb. If you can see the needle on the meter is at 60 watts. So I'll switch over to the LED bulb, and we now show 6 watts.
Wow.
So that's the difference, and the light output is approximately the same. The big thing to look for with LEDs is how many lumens, that's a measurement of light, you get for the power per watt. So with the incandescent, you get about 15 lumens per watt. And the average LED light bulb today puts out more like 50, 60 lumens per watt. So there's a gain there in the light output. Now the makers of the LEDs put them in a box to sell, and on the box they have labels. And the best label to go by is the Department of Energy's label called Lighting Facts. On the Lighting Facts label, it'll tell you how many lumens total come off of the bulb.
In fact, I think we have one right here.
Yes, this is a lighting facts label. It tells you the total lumens. And on this type bulb, this is a Ferox bulb. It has 360 lumens total lumen output. And then it tells how many watts the bulb takes, and it's 6 watts. And then it has how many lumens per watt, and it says 60 lumens per watt. Next, it has a color rendering index, which I would like to talk about.
Please do.
And then it shows the color temperature, which I'd like to talk about. And it gives you all the information you really need to compare lamps at the store. Now, one thing it doesn't tell you, and nobody knows, is the lifetime, because they haven't burned out yet. They don't seem to burn out, they seem to degrade. So they talk about lumen degradation. When the lumen degradation hits 70% point, you say, well, it's end of life for these things. And best we can determine, that takes 40,000 or 50,000 hours at 24 hours a day, 7 days a week. Now, color rendering index, if I may speak to
Yes,
that
please.
subject. Okay. Color rendering index is how well it throws light on colored objects that reflect the color of themselves. See, there's a rainbow of colors. But the old incandescent bulb that Thomas Edison so proudly brought forth 100 years ago has what's inside a little coil of tungsten wire that burns white hot, and it's called a black body. Black body is something that gives off all the colors of the rainbow. It even gives off some colors that humans can't see, but it gives off the rainbow colors from red to violet. Okay, it's called full spectrum color. The LEDs, on the other hand, mix colors due to the composition of the LED itself. So they don't give you a full spectrum of colors. So in the TV industry, you may notice that when you use LED bulbs, somehow they don't quite seem to be the right colors. So what the color rendering index that's on the label tells how well the colors match what the color the sun would give. The sun's CRI is 100. So
And
you
that's
try
right here
to
at the end.
no, it's this one, 87.
Okay. But does it correlate with the color on the lighting fact label?
No.
No, not a color.
No.
Okay.
The color on the label shows the majority color that the bulb gives off. It's either warm, cool white, warm, normal, or cool white. Cool white tends towards blue. Some people don't like that. Women, I think, like the warm white because it makes their makeup look so good. Makes them look alive, whereas the cool white makes them look like the Munsters.
We definitely don't like the fluorescent bulbs.
No.
That does not look good for the makeup.
Well, let me talk about that too. Anyhow, here I have a CIE, if you can see this, color rendation. And I have a little LED up here. Let's turn it on, if it turns on, if it likes me. If it doesn't like me, it won't turn on. It's not turning on. Oh, come on, machine.
Love technology. Here we go. Here, let me try.
Okay, something about...
Oh, there we go.
You got the magic
The
finger.
finger touch.
Anyhow, there's an unwritten law that demos should never work on TV. So what this does, it gives you the color spectrum all the way from measuring colors. Let me hold it up so you can see it better. Measuring colors at 700 nanometer, which is red, infrared going into red. And then watch the light bulb as I trace my finger across the graph. It'll turn and do all the colors,
Wow.
all the way around to blue. Now there's a point in here where you have white light. White light is a mixture of red, green, blue. In our eyes, we have rods and we have cones. The rods see at night, they see gray and white and black. The cones are either red, green, or blue, and they mix the colors for us. So in some of the LEDs, the colors are mixed to fool our eyes, but they don't fool film. So sometimes when you think it looks good, when you see it, it comes out bad on the film. So the color rendering index you should look for when you buy LED bulbs is at least 85, something closer to sunlight.
Okay.
Okay. Now, there's been some new things we've just found out recently. We have a shipment coming in from China that has phosphor on the inside of the bulb that has the full range of colors. So we're going to test that and see how that does.
Okay. So basically it's like taking a bulb where inside the actual lighting LED is emitting a different color, and then the phosphor, it then hits that and changes the color so that we are used to the color quality or the color rendering that we're wanting.
We can do it two ways. Let me show you how we can do it two ways.
Okay.
On the LED itself that I'm showing here, it has two colors in it. It has green LEDs and red LEDs. They mix, fool us, and we think it's white.
Right.
There is no such thing as a white LED. The other way to make white light with an LED is to have an ultraviolet or deep blue or purple LED and then a phosphor above it. The purple will excite the phosphor will show up white.
Wow.
Or different shades of white. I wanted to show the 6 green LEDs inside and the 2 red LEDs. Now, when they both shine, it mixes and your eyes think it's white. Also, you notice the LED is not hot.
It's like brightness you can touch.
There. Now, to us, that looks more or less like white. If it has a frosted covering, it looks very much like white. That's one of the ways you make white light with LEDs.
That's great. So the insides, from the insides to the outsides,
Yes.
This industry being such that it is a multi-billion-dollar industry. There's a lot at stake when we're talking about all the changes that are coming. I know, for example, there's a lot of businesses and some residents that have actually made the shift to LED lighting. And later on in the show, I'll be talking a little bit more about these kind of shifts that some businesses have taken, offices, restaurants, grocery stores, you name it. So from your perspective and being in the industry for so long, what are some of the common trends that we're looking at that businesses might be looking to in terms of the investment they're putting into and what they're looking to get back?
Well, definitely they want an ROI, some return on their investment, and they would like to have it within 3 years or less. So depending what they buy and how the prices come down, incidentally, the prices January of this year are going to be twice what they will be in December of this year. It's coming down that fast.
Wow.
So this is the year the light bulbs will take off, the LEDs. But you're right, they want the ROI. So one of the things they want is the most lumens per watt. The second thing they have to have is the right color temperature. I told you the LEDs are not broad spectrum illuminators. So that means if they show up on your furniture in a warehouse, it'll look probably brown inside, and you take it out in the sunlight, it will look green. So you have to be very careful to get a high color rendering index, CRI.
You said 85% or more?
It should be close to 100 as you can get. Right now, 85 is about the best they can do.
And what are some of the challenges with the technology? You're definitely skilled in terms of the engineering in the background, but if you could, in a nutshell, are there scientists actively working on ways to make this, closer to that 100%?
Yes, they are. First of all, the power, the LED is powered differently than the incandescent. The incandescent has that little coil of filament that goes right across 120 volts and just as happy as it can be. Unfortunately, the LEDs take 3 volts. So you have to get from 120 down to 3.
Right.
Or you string them like Christmas tree lights in a long string, so they add up to something close to 120.
I always have the image of taking a fire hose down to a straw.
Yes.
In terms of energy that the LEDs are consuming.
So that causes several problems. And one of the problems is if it's a electronic power supply, it gives off heat. So you got to get rid of the heat. That's why the big heat sink around the bottom of these bulbs. Different bulbs have different heat sinks and patents them different ways. And what you want is when the light's been on about an hour, you want to grab the base and see if you can hold it for the count of 5. If you can't, don't buy it.
So we definitely know the incandescent will not last for the count of 5.
No, absolutely not.
No. But the LEDs, that's the challenge that they have, and they're already making that, they're passing those challenges.
Pretty close.
I know my hand was on this just for a nice little warm thing, but it didn't burn it.
No.
So John, tell me a little bit more about what you see for the future of the LED industry, and put a little bit of a scope around what this means for our environment, the global planet, our energy consumed, all of those aspects.
Well, right now, we have fluorescent light bulbs that are very bright, but there is a problem if they break, like in a food company. So they try to keep the mercury contained. The LEDs don't have that problem. First of all, they're made out of plastic instead of glass, so they don't break. And secondly, every part is recyclable inside the LED. So we get to use them over and over. Some of the LEDs are very expensive, like the power lights. So they can be used over and over. They have a power supply in there and the LEDs. Each has its own lifetime. The power supplies will probably burn out first. There's a very weak link. The classic way to design a power supply is to have a bridge rectifier off 120 and then go into a aluminum capacitor. Those suckers get hot. You know, I've built the circuits and I've tried holding on to them. Boy, those are like boiling the juice inside, and that's not good. So they'll last 2 or 3 years, and then the light will continue to work. So there needs to be a way to replace the power supply instead of both the power supply and the light. You don't want to throw it away just because the power supply died, because the LED is still good.
And I'm curious, this is, when we speak about the lighting, you know, there's the A lamp, which is the
A19.
very common lamp that we're familiar with. Then there's all kinds of the PAR series, PAR 20, PAR 30, which measures the diameter across the light. And then there's the tubes,
yes,
which are pretty much synonymous with light in the world.
Yes.
So could you tell me a little bit more about this power supply inside or outside these tubes?
Yes. If you can put the power outside, the power supply outside the tube, and just feed the DC to the tube or the light, you're in really good shape, because one will fail before the other. If they're separate, you can replace them easily. Now back to the lights. This is a A19. 19 means if you measure across the light bulb and multiply by 1/8 of an inch, you'll get the diameter of the light bulb. The other end of it is measured in millimeters. This is a 26 millimeter base, and Edison measured them that way, so they call it an E26 base. Okay. Mm-hmm. Now the big street lights are E40 bases because it's 40 millimeters. Now you mentioned the power lights. Those are parabolic aluminized reflectors, and they're measured the same way. A par 38 multiplied times 1/8 of an inch, and you know how wide it is across the face. The socket will be the same, E26. The MR16s are measured the same way. 16 times 8 means 2 inches. Now these guys have a different kind of a base. This base is 2/10 of an inch across. These bulbs come in 2 flavors, 120 volts and 12 volts. So if you don't read the package and you push the 12 volt one into 120 volts, it's like a flash bulb.
Sure.
See, once.
Once.
Okay, now the other lights that are very, very popular, besides street lights, are the tube lights. The tube lights are also filled with mercury. There's a circular tube light that they use in very high places because it's so bright. Costco has them throughout the whole plant there. And they're also a form of fluorescent light. They use a radio frequency to excite the plasma inside the tube, and the plasma inside the tube then activates the phosphor that's coated inside the tube to give the light. So all of these bulbs are being replaced as we speak by LEDs.
Do you think all the businesses at this point are aware of what's coming in terms of this change of the LEDs, replacing the fluorescents or replacing incandescent? I mean, typically businesses don't necessarily have the A lamps. They're more common to find the tubes and the PARs and all of those. But what do you think in terms of the industry? Are they ready for us?
There's a lot of snake oil salesmen out there. I saw one the other day behind a display of LEDs, and it said, these will last 56 years. And I thought, where do they get their information?
Right.
Because we don't know.
Right.
They haven't been around 56 years. I've only been playing with them 50 years.
Mm-hmm.
So a lot of claims can't be substantiated. If they say 56 years, they ought to say something like 10 milliseconds a week or some time period too.
Right. If you say the certain amount of hours that the light bulb is good for, then if you're using the light bulb 24 hours a day in security lighting, or you're using the light bulb for 2 hours in your child's room during the night, that's a very different reality.
Correct. The other thing I've noticed on the real cheap LEDs is that they're pinkish in color. They try to get warm white, which is not pink, it's more of a brown, warm. But we had a shipment of LEDs come in from China. We had to send them all back. There's a language difference between pink and warm.
Right.
And they thought we meant pink, and so they sent us pink bulbs, and we had to send them all back. The other thing about the light bulbs I have not mentioned is there's an efficiency of the power supply inside, and there's also a thing called a power factor. Okay, now power factor shows on this machine we have. That's the one that shows digitally. What power factor means is how much, with power factor you can find out how much PG&E will charge you. If the light bulb says 100 watts on the label, and the power factor is 0.5, then you divide 100 watts by 0.5, you get 200 watts. That's what you pay for on your bill. Here's the reason. The power supply is not purely resistive. The power supply is reactive of some kind. It either has a coil or a capacitor in there. So this shifts the phase of the current from the voltage and makes it harder for PG&E to send down the transmission line. So they have to charge you more for it. You want it as close to 1 as you can get it. That's what the incandescent light does, 1. The difference between the incandescent and the LED light should not be noticeable. It should do as well as the incandescent light. So far they're close, but not a cigar yet.
Right. And what's so interesting is to typical consumers and users out there, all this information about power factors and CRI. I mean, ultimately, who do you think is really needing to pay attention to this information that you're speaking about right now? What kind of professionals out there?
Well, the buyers at big box stores should pay attention to it. Costco has had some problems and had to recall some bulbs, so they're learning the lesson. Most of the buyers for HVAC and for buildings are into the know, or at least trying to find out. Many lighting companies know that the incandescents will not be available soon, and they're very eager to get information about LED bulbs.
Interesting. Well, I think LED TV is a wonderful source for that information, because one of the passions that I have is learning about an industry that's pretty much in the Wild West stage. You know, lighting's been around for over 100 years, but the LED technology is likened to when the tungsten and the glass manufacturers and even back into the candle manufacturers, all those people got together. Well, now it's the electronic drivers, it's the semiconductor industry, the packagers, all those different organizations that are now involved in a whole new way of lighting our world.
Yes, you're correct.
So in terms of the semiconductor industry, what type of advancements are you seeing in there that are reacting to this lighting industry now making their way in?
Well, some of the bigger LED makers like Cree or Bridgelux are daily coming up with better lumen output per watt, better color. right now it's like making ball bearings. You know, they make ball bearings by pouring steel in the air and it forms little balls, it comes down and gets quenched. Well, then they sort the little balls later to find out what size they are. You do that when you make LED lights. You make your lights and then you test them, see what color they are.
Mm-hmm.
And then you put them into bins. And then if people want to buy a tight bin that's real close to 2700 Kelvin, they have to pay more money. If they buy a sloppy bin, you know, it's cheaper.
Right, because the range is there.
Well, sometimes you don't want the range. You want
True.
it to be tight.
Mm-hmm.
These bulbs, these LED bulbs are 2700, and that's what women seem to like for their makeup.
Well, and that is a very important part for the ladies out there. So, John, thank you so much for taking your time and coming up here. I know we could talk probably for another half hour or more about all of this. In fact, your seminars that I attended are a wonderful place to find out information about that. And if you could share with the audiences how to get a hold of you by email, that'd be wonderful.
Oh, my email address is john.massa, M-A-S-S-A, at massaenterprises.com.
Great. So they can get in touch with you to find out more information about
Absolutely.
either those seminars that you're providing in the Northern California area in Hayward. Is that right?
In Hayward,
In Hayward.
yes. Now, it was suggested I put some blogs on my website, which I'm planning to do, just little short, 5 or 10 minute things, telling about some of the things that are not well known in the LED lighting industry.
That's wonderful. And I'm sure lighting designers, architects, anyone that's involved with purchasing large volume of lights are really going to be looking at a whole new form of lighting,
Yes.
and they need the information to guide them properly.
Yes, ma'am.
Well, thank you very much for joining with me today
My
on
pleasure.
LED TV.
Thank you, Lindsay.